Hi, Rachel Ramsey here at Wearable Tech Expo in New York City. I'm here with Ram and Balaji from Ineda Systems. Welcome to the show.
Thank you very much. Thank you.
So tell me a little bit about Ineda Systems and what you offer.
So Ineda is a startup company. We are one of the late comers to the wearables sense in the sense that we create the technology that goes into the wearables. There's not too many companies in the world that are creating silicon SoCs which will be used to power the wearable technology. As you can see, there is so much of diversification in the wearable space together. And the reason for that is because battery life and power, which are very important in this space, is causing this diversification. We believe that there's going to be a lot more consolidation in this industry, and that's going to come when the underlayer, the hardware, is designed specifically for the wearables. And that's what we bring to the table here.
Okay, so what are some examples of devices that your technology powers?
So we can power most of the wearable devices, everything from smartwatches or even activity monitors, or even in the future eyewear devices, everything basically. So it's not limited to one particular device design as such. Anything that goes into a wearable device basically.
Okay, and you talked about battery sizes and powering these devices. So what are some challenges in creating technology for wearable technology today, and how are you overcoming it in the future?
So currently, anybody who's trying to do a wearable device design outside, they're picking off-the-shelf application processors that are designed for smartphone class devices, or they're again picking microcontrollers which are designed for a lot of embedded markets basically. So they're not specifically designed towards wearable use cases and the wearable class features and the use cases and the battery performance and all of that. So we are working on silicon solutions specifically targeting the wearable use cases. So basically we can scale the performance and power right from always on use cases where we can go from microwatt to thousands of DMIPS kind of performance basically. And again, we can cover a wide variety of the sensor interfaces with advanced digital signal processing embedded in the design. And again, we can also cover what are your always-on use cases, like for example, you're just trying to monitor the activity on the accelerometer, or actually you're trying to pair to your smartphone over a Bluetooth low energy wireless connection, or you're actually trying to detect some voice commands, like if you want the device to be continuously listening to you and check the voice activity detection and then trigger the other logic pieces. So all those kind of use cases are covered actually with our silicon device, and we are hoping that as we go forward we can learn more and more about the devices and again fine tune the use cases to make sure actually we can really take it to that low microwatts or even potentially to low nanowatts in the future.
Just to add to that, right? Today, if you look at any wearable device, the challenges that you have is you have a limited sensor capability. You have a single accelerometer. In fact, I think there was a study that was recently done which compared, which fitness device actually measures your number of footsteps properly. There was another study which says that, okay, I can measure all your walking, but I cannot measure how much calories you're burning if you're doing swimming or something else. People are trying to integrate this using software solutions, but what we are trying to bring to the table is you can do this really, really easily if you can do this in hardware. And when we can do this and you can have, let's say, a 30-day battery life or a 60-day battery life, now suddenly a common man can use it much more efficiently. You saw some of the presentations here today, right? They said, this watch is really bulky. And the reason for that is because the technology doesn't allow you to create a nice small form factor. So we are designing it in such a way that your silicon will be really, really, really small and it has all the features embedded inside it. So now any designer can take this and create a really smart looking device, and tailor it for a male or a female or an elderly person or a young kid or an animal or whatever it is. And they can design it in such a way. And if it says, okay, I put it on you, and you walk around and let's say you want to measure your calories. You're walking and it does that automatically. If you're swimming, it does it automatically. You're dancing up and down, it does that automatically. And even better, we'll have the capability to, when you just come home, and let's say you have a wireless, Wi-Fi hub at your home, it automatically can upload this data to your PC or your smartwatch or your smartphone or to your cloud, right? And maybe to your doctor's office if let's say you're have a medical situation, and all of that can be seamlessly done because of our technology. So, just like Intel and AMD did wonderful things for the PC world by creating, everybody remembers the Intel Inside campaign, which, basically they are the brains of the PC. So that's what we want to be. We are the brains of the wearables. So that's that's our game changer, I guess.
Got it. And you're speaking in a session tomorrow at the conference. So can you tell us a little bit about what we can expect from that and what you're seeing in the industry in general?
So I'll be talking about the wearable processing unit SoC that we are designing from scratch, and this is the industry first product in this area actually. So most of the processors outside they are not really designed for wearable today. So we are actually going after this, and it can really increase the computational capability of your wearable devices. Today the wearable devices are mostly singular in nature from the applications or even the use cases basically. So we can really make them smart wearables once you get more processing power, especially with the low power consumption and with extended battery life. We are expecting there will be open APIs and a lot of third-party applications that will be coming in, and these devices could become like really smart. So how today I cannot live without my smartphone, we are actually hoping that by powering the wearable devices using our silicon, we're hoping that they can become equally smart, and they will become pervasive the way we see today on the smartphones and everything. So,
Excellent. Well, thank you so much for your time, and enjoy the rest of the show.